So I'm going to introduce Yiftach. Yiftach is the founder and CTO of Redis Labs. He's been doing this for quite a long time. He's been involved in quite a few companies who've had successful exits before. So he's been heading up all the technology and building our team, who's now built out the products that we offer. And those two products real quickly are, one, we run Redis Cloud, which is a Redis as a service running on Amazon that you can use through by itself on Amazon or through Heroku. We have quite a few customers on Heroku. We also run that same technology on Azure, and we run the same technology on Google Compute Engine or platform, and we run the same technology on IBM software. So it's the same core technology for running your cluster of Redis. And recently, in the last year, we came out with a software product that does the same thing. So you can now run that in your own data center and have your own cluster of Redis. And we call that Redis Labs Enterprise Cluster. So Yiftach has been developing, guiding, and building the team to build this. So he's got a lot of experience, and I'm very happy to be able to introduce him and invite him up to share with us his presentation. So thank you. Let's hear it for Yiftach.
So hi everyone, and thank you for hosting us today. I'm going to talk about how to run real big data on Redis. Real big data is everything above Tera, even close to petabyte, but at a low resources. Shall I ask how many of you know about Redis? I just came from a CIO meetup. Only 2 out of 20, which is strange, knew what is Redis. This is very strange. It's #1 NoSQL in satisfaction according to recent survey. It's #1 growing database according to DB Engine. It's #1 database on container. It's #12 most among all the software developer tools that developers like. And it's the most exciting community and the most largest community on Earth. It's of course created by Salvatore, who is now Redis Labs employee. And by the way, we just changed together with Salvatore, the definition of Redis, because people used to say that Redis is a key value store. Come on, it's not a key value store. You know why we changed it? Because when we pitched analysts like Gartner, they compare Redis to S3. S3 is a key value store. It's a competition. No? So it is not only the in-memory part. I think that most of you know that most of the things that Redis provides is the data structure, the things that you can do with Redis, not only the fact that it is very fast, which is important, of course. But, and it can be used as a database, as a cache, and as a message broker. Few things about us. So we are the home of Redis today because we sponsored the community. So Salvatore is actually part of the team. And most of the changes in the open source during the last year came from our team. And as Dave mentioned, we have 2 types of products. One is called Redis Cloud, which is Redis as a service, and one is called Arlic. It is Redis Labs Enterprise Cluster that you can download and run it everywhere. It is very interesting that we have a model or deployment model in which you download and install it on your own infrastructure, but we manage it from remote with our DevOps. We found it very, very attractive for people. Just to share with you some numbers, so we have something like 5,310 customers, over 34,000 free users, over 115 databases under management. Every day we have something like 200 new databases on our cloud service. And we raise something like $30 million. This is just an overview, but it is important why people are choosing in-memory database. So you all developers, you all know how the app should work, and usually there is a well-known standard today that your app should respond around 100 milliseconds. This is very challenging for all of us, but this is something that everyone is wishing for. This includes the network and the data center. If you take into account 50% of this go to the network, so you left with 50 milliseconds inside the data center, which includes multiple interaction with your database, multiple interaction inside your application server. So you need to have a database that responds in less than 1 millisecond. And you cannot have it without in-memory technology. Same goes with big data. You want to cut the time of Hadoop or Spark processing from hours and days to minutes and seconds, and in-memory is important. We are doing a lot of stuff in this space, but I'm not going to talk about it this day. So the main issue today, the main questions that I want to cover today is Redis is expensive. And a lot of people still think that you cannot cluster Redis, still think that you cannot make Redis highly available. So let me share with you some numbers. We have been running cluster of Redis since 3 years ago. We had something like 500 node failure events in the cloud every second day. We had something like 30 complete data center outages every 1 month, especially on Azure. For those users who enable in-memory replication, data persistent, backup, and across data center replication, we never lost a single byte of data. So Redis can be highly available and scalable today. Where's the Basho guy? You don't need Basho to run Redis highly available with cluster. But I'll leave you to speak of it. So let's talk whether Redis is expensive, and sometimes it can be expensive, but there are some use cases that we need to look very carefully and see if there are other alternatives. For instance, Smobly, I don't know if you heard about this company, they are competing with Instagram. And their data set is not huge, it's half a terabyte. In memory, it's relatively large, okay? Something like 400K writes per second. 400K writes per second, 1500 reads per second, and a relatively large object size, 40K. With any other technology, they should have a cluster with something like 30 nodes, 120 gigabytes of network. And with Redis, they can serve everything with 1.5 gigabit per second over 6 node cluster. So it's clear what is more expensive in this configuration. Another example, there is a well-known benchmark that everyone is doing today. How many servers you need in order to achieve 1 million writes per second on Google Cloud? I don't know why Google Cloud, but everyone is doing it. So the guys from DataStat reads 300 servers. Aerospike 50, Couchbase 50, and we did that with 2 servers and data persistent over Google Cloud with relatively low IOPS and with data persistent. But Redis can be sometimes very, very expensive. Here is an example. Let's assume that you have 10 terabyte data set. Usually in distributed databases, you need to have 2 replications, that means 30 terabytes. With reserved instances, this will cost you over $2 million. This is a lot of money. We have a patent that can show you that you can have only 1 replica and still be a real distributed server database system. Because we do the quorum by the server, not by the shards. So instead of using 30 servers, in this example, we use only 21 servers, and we save 30% of the cost. But this is not the end of the story. Let's look at the new memory technology, in-memory technology. There is a well-known assumption that the memory price goes down every year. This is completely wrong. If you look at the memory prices, it is waves. Sorry. It looks like waves. Today, DDR4 is something like $15 or $14 per gigabyte, much more than the average. So DRAM is about $10 $10 per gig. This is the cost of the chipset. The performance is very impressive. It is 0.1 microsecond for read and write on average. SCM, do you know what is SCM? Storage class memory. Have you heard about the 3D crosspoint announcement by Intel and who was it? Micro? So this is actually a chipset that combines both RAM and flash together. Okay? It's much faster than flash, but still 10 times slower than RAM. On the other hand, it is something like 70% cheaper than RAM. So $3 per gigabyte. 1 micro read and write latency. Flash can be something like 100 micro for read and sometimes 1 millisecond for write, and it costs less, $1. Why I'm saying all this? We developed during last year a technology called Redis on Flash. It is not open source yet. Not sure it will be open source. Do you know why? Do you know why it is not open source? Any guess?
Because it's a good idea.
It's a great idea. It's a great idea. But you know, everyone today is using, especially AWS, they have the culture of taking all the open source technologies on Earth, doing a service around them, and contribute zero code back to the community. By the way, Basho guys, you should also contribute something to the community. It's about time. So we took the open source and made it available on Flash. How we did it? It is not trivial. It took us about 1 year to develop. But the concept is, let's put the keys in RAM, the key data structure of Redis. Let's put the hot value in RAM and the cold value on Flash. And let's treat Flash as a RAM extender. So what is in Flash is not in RAM. What is in RAM is not in Flash. If something happened to your Flash, you still need to use the regular data persistent mechanisms of Redis. Okay? And we also add a way to control the ratio between RAM and Flash with a slider. It looks easy, huh? It is not easy, because if you don't have enough RAM, what you do if you just move the slider a bit, we add more server behind the scene. We just scale out the cluster for you in a transparent manner. But this way you can achieve performance which looks like this. This runs on IBM Power 8. If everything runs in RAM, it's about 1.5 million operations per second, sub-millisecond latency. And then, if we put 10% in RAM, 90% in Flash, and the access ratio is 50%, okay? The access ratio, I mean how many of the requests are accessing the RAM, how many of the requests are accessing Flash, you still reach 200K ops per second at sub-millisecond latency. This is much more than any other database on Earth, and it's running on Redis. So now let's get back to the costs that I showed you in the previous slides. So 2 replicas, more than 2 million. 1 replica, 1.4 million. And then if you run on different instances, of course, because you need a lot of I/O, this is I2 instances of AWS, you can host the same size of data set with only 350K per year. This is a huge achievement. 83% reduction. This is probably the reason we are not open source. But let's now talk about a use case which is not, specifically Redis. It's interesting for everyone. So we call it the Geno problem. We have one customer that had this. He decided to switch his Hadoop data to Redis in order to accelerate the processing. And the key is much larger than the value. 32-byte key, between 5 byte to 12 byte value. And remember, in the Redis on Flash case, we put the key in RAM and the value on Flash. And this guy has 250 giga, well, it's not called giga, but it's easy to say, keys is 10 power 9, or between 250 giga keys to 250 tera keys. Okay, this is better. This is how it looks. This is the key. These are two examples of values. Don't ask me what is the IE or it is inside end sequence or in edge or whatever, which one of them. But if you put everything in RAM, because of the overhead of the key, because of the overhead of the value, and because of fragmentation issues, you need to have 31 terabyte in memory. Probably only Twitter can host it. And if you put it on what we did in Redis with Flash in a native manner, still 22 terabyte in RAM, only 2 terabyte in Flash. Because it is in Flash, there is a little bit less overhead, and this is why it is in total 24 tera and not 30. So can we save more? So first of all, if you have this problem, you can probably do some encoding to the key and the value and be able to, in this case, we encode these A, G, and C, and T with 2 bits. At the end of the day, we managed to compress the key to 62, 64, 8 bytes instead of 32 bytes or 31 bytes. The same we did to the value, which is now, again, 8 bytes. But this is not the interesting part. The interesting part is that, Redis has hashes. Everyone knows hashes. So we wanted to reduce the number of keys because there is a lot of overhead around the keys. So we decided to aggregate these keys in hashes. How we did it? We just did an hash function, which was CRC64, on the original key. Okay? In order to say in which bucket, in which hash table, this key will be stored. Is it clear up until now? And I'll talk about the M part of the acquisition. So the real operation will now will be, let's do HGET of the hash function of the encoded key. This is the way we are doing the get. And the set operation will be similar. Let's set the hash function over the original key with the encoded key, okay, and the value. Too much information. I feel it. What is the interesting part? The interesting part, you take a lot of key values and you put them on hashes. And then you need to decide what should be the size of the hash. How many entries will be there. Why it is so important? Because for those of you who work with Flash, Flash works at 4 KB IOPS. Okay? So whenever you want to access a key, you want to access a single hash table, and you want this hash table to be limited to 4 kilobytes. Otherwise, there are many IOPS. Too many IOPS, you are limited in throughput. So this is how we designed it. So we took the hash block, and we just reduced the overhead. We calculated how much overhead can be with the hash, with the Redis hash. And we got to conclusions that we need 266 hash entries. So to be on the safe side, we cut it to 200. Does that mean whenever we have the original key and we do CRC64, the hash function, right, we need to take the prefix of the first 31 bits and then decide to which hash bucket it goes. This is a very nice hash size distributions. 200 is here. Reduce here, reduce here. And this is the memory size. Only 55 gigabytes in RAM. So, but you know, this is only if we keep only the key parts. We want also to keep the hot values. So we increased it in order to maintain 10 to 90 ratio between RAM and flash. Okay, so we increase it to 500 gig. And only 4.5 terabyte on flash. The end result is this. 2 million with the original Redis string. 2.7 with the pure Redis on flash, because the instances here are more expensive. Less instances, more expensive instances. If we use, now forget about the stream, if we use Redis on RAM, this is a mistake. On hashes, this will be even cheaper, 300,000, which is quite good. But you can host everything with less than 50K a year if you do it correctly with Redis on flash. And this is 4.5 terabyte. Yeah? Almost in memory performance. This is it. Do you have any question?
I got a question actually about the last slide.
Yeah.
So as far as there's basically the last one, the Redis on flash and hashes. So basically the stream is the extended, and then the hash and flashes, hash and flash is also shrinking it down and also using the separation of RAM. So I guess actually if you can explain that last one a little bit more.
Okay, so first of all, this is a mistake. This is Redis on RAM with hashes. I'll fix it.
Real time.
Yeah. Okay. So if you do anything, if you do nothing, just take the use case when you have a lot of keys. Do everything with hashes. This is by its own 90% cheaper in this case. In this specific use case, we just, this is the RAM that we used. By the way, we could use much less RAM, but in order to reach the performance that I showed you previously, we need to maintain 10 to 90 ratio between RAM and flash. So we keep it half a terabyte. And then 4.5 terabyte in flash. And these are the instances. You only need 2 instances. Is it clear?
Of the money, that is smaller, what part is from saving the RAM and what part is from computation, like processors?
Again?
Like you have RAM and processor, right? From 2 million to 50,000, whatever the savings that are there. What part?
2 million to this?
Yeah.
So we move to hashes. It's here.
No, the next one, 50,000, right? The last
Yeah,
one.
and then we move to flash.
Flash, yeah.
Yeah.
So, of the savings you made in terms of the cost, where did the savings came from? Are they from the RAM or easy to, the CPUs kind of stuff?
No, it's the number of instances. Here you need 23 instances. Here you need 155 instances. Here you only need 2. Although these are larger instances, everything is AWS, you only need 2.
But this really just covers the storage component, right?
Yeah.
As opposed to the computational.
It's RAM versus flash. It's the cost of RAM versus the cost of flash. And as I mentioned earlier, the cost of RAM not going to be cheaper. And believe me, we met with the CTO of Amazon. I don't know what happened with Redis, a week ago, 2 weeks ago. They're not going to reduce the price of the instance with the IRAM. They're not. What about you? Probably not. There's a lot of, basically RAM is more expensive. You need more power to cool it. And it will remain like this forever, I guess. And by the way, there are only 3 cheap RAM manufacturers today. In the past, there used to be 5. So there is no real interest to reduce the cost. If you don't have more questions, I
I-
have a question for
Can
you.
you go into a little more detail on the performance difference between, and you kind of alluded to it, that it was minimal in terms of the difference, and you may have talked about it and I missed it.
Okay. Yes, it could be a huge difference. So again, what we did here, with Redis on Flash, again, we put 10%, usually you can put more, 10% of the data on RAM, 90% of Flash. And then we developed a load generation tool that can determine the access pattern to your data set. How many requests going to the RAM, how many requests going to the Flash, which is the important part. Okay. This shows you that in case that all the requests goes to RAM, it runs 1.5 million hops per second, some millisecond latency. By the way, this part is under some millisecond latency. This part is under 10 millisecond latency, except the last one. But if 20% of the requests go to RAM, you achieve 160 hops per second, which is 1/10 of the original. Still very high, by the way, if you compare it to any other database, but it's much less than the other.
So, if you compare it to any other database, was this customer looking at any other options and
Yeah.
how, and what scale compared?
Yeah, I mean, they tested this in Cassandra, Aerospike, and Couchbase. One of the problems that you see in these databases, I think, is you usually see it in Cassandra, is not the scaling problem, it's the consistent of the performance. With Redis and also with Redis and Flash, that the performance is predictable. It's consistent. Doesn't, glitches. So let me share with you some very interesting data. I'm sure you have the same data on Rackspace. When we met with Warner 2 weeks ago, we asked him a generic question. Can you tell us the ratio between NoSQL and SQL deployments on AWS? Do you have any idea?
No SQL.
50-50.
Say something. Any idea? RDS is a great service. RDS is the MySQL service of.
Are you saying just like Redis instances on?
No, forget about that.
No
NoSQL in Jira.
But I'm saying, are they measuring it through their like NoSQL as a service, or just you running Redis on the EC2 columns?
I don't know how it's measured.
That's different.
Yeah, I don't know. I didn't ask. I guess based on the service. But RDS is the largest deployment of MySQL on Earth. They are happy because they don't pay $1 for all of it. So the ratio is 70% NoSQL. It's amazing. 70%.
Up to 70%, how much is, did you know how much is for DynamoDB?
I don't know, but DynamoDB is their best service. What?
Was that percentage instances or percentage size?
This is always a good question, whether it's money, size, instances. I think it is instances. More questions? Go there. Thank you.
So my name is Derrick Johnson. I am the product manager for Object Rocket Redis for Rackspace. And we manage a couple products. Actually, I'll just jump into the introduction. We manage a couple products around Redis. We manage the Object Rocket Redis product that is on the Rackspace infrastructure. We do offer direct connectivity to AWS. And we also offer the Redis to Go product that is a little bit different than our Object Rocket Redis, which is meant more for a production-worthy HA performant type product. And so the majority of what we're going to spend the time on today is talking a little bit about Object Rocket, or within the context of Object Rocket. I brought with me today Andy Woodard, who's one of our support guys, one of our customer data engineers. And what we really want to focus on today is a lot different than what Iftar kind of walked us through from the standpoint of different types of use cases. This is going to be more about what are the common types of challenges we see, whether it's using Redis or whether it's us managing an infrastructure. And why I felt it was relative from a community discussion perspective is if you think about whether you're self-managing Redis yourself, if you're self-hosting, or if you're using a managed service like ourselves or like Redis Labs, what are some of the common things that we see on a day-to-day basis? Whether, like I said, it's things that we see on the infrastructure side or whether it's actual issues that customers are facing in using Redis themselves. And so I'm going to kind of go through these relatively quickly because I want Andy to spend the majority of the time going into some examples. But there's a lot of good reasons to self-manage. It may be a dirt simple use case that you have. You may have Redis expertise in-house. You may be, from a security perspective, have requirements around you needing it behind your firewall within your infrastructure. You may be all about visibility, control, and performance. There also may be some really good reasons why you want a managed service. Whether you're interested in database as a service from the standpoint of having that fully managed solution, you want to use your resources elsewhere, you want to leverage someone else's expertise, and then also you're interested in visibility, control, and performance. So at the end of the day, any managed service, the key value that we provide to you is expertise in helping you to get through your day-to-day needs as it relates to Redis. Service is a combination of proactive and reactive. I'm not saying anything that's a surprise. At the end of the day, we deal with a combination of what are the things we can anticipate and what are the things that we react to. And one of the key pieces of this is the data that we have up front from the customer. So information, information, information. And one of the things that we struggle with every day is how do we get customers to engage such that we've got the right amount of information up front. Likewise, if you're going to host Redis yourself within your own infrastructure, it's all about what you know about your use case. It's all about what you know about what your infrastructure is going to look like. So it shouldn't be a surprise that we struggle with the same things that anybody who's setting up Redis in their own infrastructure would struggle with. It's a matter of how we get that information from the customer. The one thing I'll say is if you're ever interested in a managed service and you're going down the path, engage with your provider. Get as much information to them as possible up front so that they can anticipate any problems that you're going to have and be able to offer you that managed service. So from the standpoint of the goal at the end of the day, proactively address as many customers, as many issues as possible and react to anything. Some of the types of data that we're talking about is, what is your Redis proficiency? What is your typical use case going to be? What are your usage patterns, programming languages, drivers, clients, the basics, the blocking and tackling of what you know about your use case and our ability to react to it. From a usage evolving perspective, there's a lot of documentation that's out there. There's a lot of resources that you guys have access to, that the community has access to. The Redis community remains a very strong community. We're continuously seeing more and more data out there. And the use cases really drive the support needs that customers have. Again, whether it's you internally or whether it's using a managed service, you can see from the use case that we just kind of went through just now how challenging that can be. But we're in a unique position to share some of our experiences and some of those details around what are the things that customers see. And so with that kind of laying the groundwork around support models and the types of data that we're interested in, I'm going to turn it over to Andy, and he's going to walk you through a series of common challenges that we face on a daily basis.
Okay. Hey everyone. So I guess just dive right into it. One of the things that we see a lot of is we see customers that love to run staging in production in a single instance. And the problem with that is, as far as Redis is concerned, the LRU counter, the mechanism in there, is for the instance, is the process wide. So what I've seen a lot of times happen is customers will actually have a production keys being evicted prematurely because in lieu of their staging keys, right? And they put in a support ticket and say, hey, what's going on? My Redis is acting really weird. It's not doing what I expected to do. Well, then we have a couple of conversations. We find out that they're storing staging sessions, like mock sessions, that are pushing out some of the LRU. They're maxing out memory, pushing out some of their production keys, and they've got customers putting in tickets with them saying,
why I just logged in 5 minutes ago when I'm not logged out again. What's going on? Lost my card, I lost everything. So if you have anything in there, we've even had customers that have asked us to please switch to using all keys instead of using like volatile, which is something that a lot of people will use as default for the max memory policy. And then they come to us and say, hey, what happened to some of my data? We had some pretty important stuff in there, and we'll tell them, like, look, we gave you the caveat that you're going to use all keys. That means that it's going to evict anything that you have in Redis as long as it hasn't recently been used. This is a very interesting thing because Magento likes to store config data in Redis. And a lot of people like to run all keys with Magento because they store cache information in there, and then they start evicting some of their config data, which is pretty cool. Another thing that we see, this is more of a front end, not necessarily for Redis, but dropping connections elegantly. There's a variety of drivers out there to connect to Redis. With that, there are some that do pooling and some that don't, and some that handle connection interruptions gracefully, some of them that don't. So one of the things that we'll commonly see is people will put in requests saying, hey, I'm getting these weird errors, like Redis Connect errors in my application, coming straight from the driver, so they think Redis is down. And so what we do is, in front of our Redis implementation, we run HA proxy. So what we do is we run through HA proxy and we look for the logs, and we find that the termination state a lot of times is that there are ungraceful closes coming from their driver. A lot of this happens to be, unsurprisingly for some, I guess, is C# driver. A lot of customers, writing .NET, there are two C# drivers. One of them is, I can never remember if it's not doing pooling or if it's doing pooling incorrectly, but we see a lot of CD termination states coming to HA proxy from that driver. And anybody who's ever worked with Linux, hopefully all of us have, not closing those connections gracefully, and if you've got a ton of them, you will exhaust the open file handles on your server, which means that you will now have no connections available. We have seen this. We've seen this before. This is one of the things that led us to looking at the connection pooling in the .NET drivers. With the driver change, this fixed the problem. However, it wasn't exactly ideal for the customer because they had a very interesting use case. The use case itself wasn't interesting as the way that they implemented it. They were just doing a cache over SQL Server. Anytime they had a connection problem, Redis would sleep for 30 minutes. Like their app to Redis would sleep for 30 minutes, and then they would just pound SQL Server. So the reason that we found this out was because they were hitting 99% load of their SQL servers because their Redis cache was no longer available. And it was because their application decided to sleep for 30 minutes, which anybody here who's ever implemented a caching mechanism knows that if you have any network issues, you won't sleep for 30 minutes. So we fixed that, but it was definitely an interesting one for us to chase down because the lesson learned here was that there are two ways that you can implement HA proxy. There's a config option where you can log ASAP, which will log as soon as the connection is open, and that's it. The other one is if you take that option out or you don't run that in config, it will log the connection closed, which gives you termination state, which makes it a lot easier for you to troubleshoot connection issues because you can actually see what's going on. Networking, well, more networking, but latency is another one. As we've already heard about how awesome latency is, and you want to get that 100 millisecond end-to-end experience for your customers. Latency is a huge factor. So we've had the opportunity to work with a couple of customers who thought that they were going to be able to get sub 1 millisecond latency by hosting their Redis servers in IAT, which is in Virginia, and having US West instances connect to it. I don't know if anyone's familiar with networking or physics, but that's... So the easy answer there is get your application as close as you possibly can. When you're going with a service provider, what does that mean? That means if you are in Google, then you want to be as close to your infrastructure needs to be as close as possible. It's a little bit more difficult with some providers than others, but for everyone at Rackspace that we host, they usually go over the Rackspace service net, which is just an internal network. So it's all sub 1 millisecond latency, super fast, everybody has a good time. And then we have Rack Connect, which connects the cloud servers to dedicated. Gives a nice little network in between the two. Generally same low latency. But the other thing is that we have direct connect. So in the situation where we have the customer who is in US West, versus trying to put the Redis in IAD, that wouldn't work. But if they were in US East, then they would be able to talk to our Redis instances over Direct Connect, which is going to give them that super fast connection. So the conversation is usually pretty short with latency concerns, because they say, just don't put a bunch of distance in between your database and you're going to be okay. But I think everybody is thinking that they're used to using this servers that are side by side. Sometimes they're on the same rack. Sometimes they're VMs on the same hypervisor, which they don't think about when I'm using a service or going data center to data center. What does this look like? So scaling Redis. So another problem that we recently had was we had a customer that started off at about 2 gigs of Redis. They were using Magento. They've getting ready to hit a very busy time of the season for their website, as most people are, but even more so in October for this customer. And they started off without knowing any data about what their traffic was going to look like. They didn't have anything to compare it to from last year because they just started using Magento and they just started using Redis. They didn't know anything about really what this was going to look like. So they started off small. Well, we have the ability to do vertical resizing straight from the UI for the instances. So what this customer was doing was they had to quickly move. I mean, basically, the eviction was kicking in, and it started moving keys out of there. And they're one of the customers they're not invalidating their cache. They're not setting any kind of expiration on the cache, so they would hit max memory. So they would resize. So they resize to 5 gigs. And then a couple of days later, they resize to 10 gigs. And then a couple of days later, they resize to 20 gigs. And through this whole process, there's an interruption through resize because we need to change where our load balancers are pointing to the masters and everything. So conversation with this customer, as you can imagine, was pretty interesting because there were a couple of lessons on capacity planning that needed to happen. And we had some good conversations. But one of the best things to mention was it's Magento. So you've got full page cache, you've got sessions being stored in Redis. No expiration being set on full page cache, expirations on the session. Let's talk about that a little bit. So we got them kind of in a space where they're going to start adding TTLs to their full page cache, which if you're running a cache, you should be doing that anyway. Either that or have some other type of cache invalidation mechanism. But through this process, we found a really cool corner case for the replication buffer in Redis. The replication buffer in Redis is set to a default of 128 meg, I think. So what happens is when this large customer storing 10 gigs in memory, trying to move to a larger size, the replication that's happening, it tried to allocate more RAM than what the buffer configuration was, so it caused the replication to fail. So that caused the resize to fail, and we had to go back in and figure out what's going on. So what this led us to do was now whenever we implement Redis, we actually use a percentage for the replication buffer instead of just setting it to a value or leaving it as a default. Because as you can imagine, as you start getting into the 50 gig or the 4.5 terabytes in memory and you have to do Redis replication, you gotta make sure that you have a large enough buffer. So we'll lead into talking about the decision to go with AJ Proxy now. So we used to use cloud load balancers at Rackspace. It's similar but not really to elastic load balancers with AWS, where it's just a cloud-hosted load balancer solution. You have the ability to do SSL termination and other cool things. The problem is that it was a black box. Like, even to us, we didn't have the ability to go in and hack on the code. We didn't have the ability to go in and change configs and stuff like that. It was meant to be used just as an endpoint, which for some use cases is fine. Unfortunately, for our use case, trying to provide the service, it wasn't going to work for us. So we switched over to using HA proxy, where we provision and we manage the HA proxy nodes ourselves. This allowed us to be able to get all the logging that we needed about, like I talked about, the connection termination states, the amount of data that was being passed during the connections if it was an effective connection. We also have the ability to make it HA. So, and we didn't have the problem of having noisy neighbor with some of the shared networking solutions that are out there. So we actually give a pair of HA proxy nodes per HA Redis setup, which allows us to do HA proxy failover. It allows us to, these separate instances prevent noisy neighbor from happening. A lot of times there are things that you want to use like a managed service because you want to take all of the headache of managing something away from your team, right? Our team was a team that was looking for that does this, that we implement things, we manage things, we engineer things, we hack on things, we make things better, and our whole job is to make this service, right? So using the managed service was kind of a good thing at first to help us get the product to market, but we slowly realized that we really wanted to do it ourselves. We wanted more visibility, so we did it. So we ran into a couple of issues with idle timeouts because we found that there are a lot of people who like to implement PubSub and subscribe to a channel that never gets any messages published to it. So when you have an idle timeout of, say, 50 seconds or an hour or something like that, some applications, some frameworks out there don't have the right exception handling around these. So what we were seeing happening, and I believe that there's a particular PHP framework out there that does not have any exception handling around this. They would connect to, they would subscribe to this channel, and then they would wait for some period of time, and the message would never come because either they weren't using that functionality or they weren't busy enough to get the message, and their application would die because it wasn't meant to handle the connection fail from the timeout. So we had a good conversation, a little exercise in timeouts, and the reason why load balancers and other networking gear have timeouts. And as good of a developer as you think you are, the person that's sitting next to you may not be gracefully closing your connections, and that's the reason why we have to have things like idle timeouts. So we ended up making the change, which was really easy for us to do in HA proxy. We set the timeouts to 12 hours, which 12 to 24 hours is a lot of times is pretty standard for what you see for idle timeouts on a lot of networking gear out there. And we wanted a good balance. Some people have asked us if we can just completely turn off idle timeout, and no, not a good thing. But the log access was another thing that was really helpful. The cloud load balancers have logging. There's a way that you can turn on a little bit more verbose logging and have it sent to cloud files on Rackspace. Still didn't give us what we needed, so the HA proxy logs are a lot better. And the great thing is that we share these. I mean, whenever we see things, like I said, drivers that are acting a little weird, not pulling connections correctly, we can actually provide data from the logs, which is super helpful. So now we have a couple more stories, and I've kind of talked to these a little bit, but I would love to say that every time you give somebody advice, they take it, but we all know that's not true. So we had our own kind of like Redis Icarus customer that had a giant instance, and they had somewhere to the tune of 40 to 50 million keys stored in Redis. And what they love to do is they would love to do sort on all 40 million keys. which is extremely CPU intensive, and it's just a bad time. But not only would they do that, they would also use flush all. Because they would decide at some point that once they sorted all this information, they got what they needed, they would flush all 40 million keys, and then write another 40 million keys. Multiple applications doing this, mind you, it wasn't just one. So, kind of had conversations about maybe thinking about doing sort somewhere else, doing sort in a different way, maybe not sorting all 40 million keys at one time. And another thing that they would love to do is not only would they sort all the keys, they would also use keys star. And they would return all 40 million keys at a time. So we had conversations around like not doing a lot of these things that are very, very bad for Redis and the CPU running this on. We talked about multiple applications, so we talked about breaking this up into smaller instances, so we're not putting 40 million keys into one instance. And this is where kind of clustering comes into play, but we weren't looking at it from a proxy clustering situation. It was more like, let's give the applications, their own little sandbox to play in, so they're not going to start doing some of these very bad things to everything and bringing the entire application down. The other problem with 40 million keys and the way that they were doing updates is that they were triggering persistence a lot. So even with throwing an additional core on there for the thread that kicks up for VG save, we were still hitting very, very high CPU. They were not very receptive to splitting into multiple instances. Having a function string for a database for your application is just very difficult to manage. It's so hard. Nobody uses more than one database these days, right? So it was difficult, and they ended up moving on to self-hosting, and they had the exact same issues that they had with us, self-hosting, because it wasn't the platform that we were running, it was the way that they were using this. And we would really love for them to not do it, but all the time they still fly too close to the sun and they crash servers. Then the other thing is we recently were introduced to a customer who is doing Redis clustering with 3.0, and they have a lot of servers. And while Redis itself is fast, and getting and retrieving data from Redis is fast, one of the problems that this customer is seeing is that when you start having hundreds of nodes and you have to talk to a lot of those nodes, given network latency, it's going to cause a slow return on some of these keys, especially when you come in and say hi to node number 1, and the key that you're actually looking for is on node 152. Then by the time node 1 gets all the way to node 152, it's going to take a bit of time. So this is where things like twin proxy that Twitter put together, or Codis, which is the Go equivalent of twin proxy, allows you to do this in a little bit more elegant manner. There are other customers out there that are running things like 40 terabytes of Redis that are not Twitter, that have implemented their own proxying and metadata store. One of the best things for clustering Redis is you need to figure out if this is really what you need. There's a lot of people out there that just have a huge stack and they want to store a bunch of Redis stuff in there and do a lot of bad stuff. Not a single server running Redis with 50 gigs of RAM and a CPU and some disk for persistence. It's not a terrible thing. If you're going to use it for standing things, you're not going to go store 40 million keys in there and flush them every day or so, and then rewrite them all and then sort them and everything like that. You could do all these across the cluster, but really you're still not using Redis the way that you should be using it. It's just that you've spread the load out across multiple servers. I guess that was it. So, does anybody have questions about any of it? All of it? That was okay. Yeah.
How many, in your experience, how many people are using PubSub? just within, you know, your average cross-section of clients?
So, very few people that I've seen are using PubSub outside of frameworks. And then the frameworks, they're generally not using the functionality of what those are for. Like, this particular framework, I believe, was using the PubSub as an event broker. So what was supposed to happen is that it was a queuing framework, and I believe that there were supposed to be messages that were supposed to be put on the channel that a couple of the app servers were supposed to subscribe to, or workers that were supposed to subscribe to, but I don't believe that they were using the functionality. A lot of what we've seen PubSub-wise has just been exactly that. There is some connection on the other side, like a WebSocket, and the information is just supposed to be some type of like real-time event that's supposed to come through. Majority of the PubSub that we see just comes from Sentinel, since we're running HA. So, yeah.
In your experience, like how many people use like Redis cluster coming, which came in 3.0, or use some other like version of cluster, like using plain proxy or something like that?
So the one customer, this one customer with clustering was the first time that I've seen a customer using 3.0 with clustering. We've had customers use 3.0, but not any of the clustering functionality. As far as Twem proxy, we have a customer that's running on their own that used an idea like Twem proxy, but they coded it themselves. They have a couple hundred nodes running 40 terabytes of Redis in their cluster. And they hired 2 people to manage the entire thing solely on that project because it's pretty large. They host a lot of their other data with us, and that was the reason why we knew they had this massive Redis cluster. But they told us that because the way that they poorly implemented Redis and Redis clustering, that they would never wish that on anybody else, so they should be in-house. So,
I think to kind of go in a little bit more detail, we hear a lot of discussion in the sales process about clustered support, and there's definitely an interest that's there. But in terms of, is it a broad adoption of a solution? We don't see it as much. And I'd be curious to see what you guys say there as well.
We have our own clustering technology we developed since 3 years ago. We have 1,500 clusters.
What percentage of your total customer base, though, is using a clustered solution?
So, 1,500 out of 100.
is that paid or?
Yeah, most of them are. No, you cannot do cluster.
You can't do cluster.
Oh, no, but I mean like out of your entire customer base, because I saw that you had tens of thousands of customers on like a free tier.
Yeah, we have many free tiers. So out of the total databases, it's something like 1%.
Okay.
But still, it's over 1,000.
Yeah, I think when you have technologies like React and MongoDB and Cassandra and Couchbase, and you see all these clustering solutions, like everybody wants every NoSQL to do the same thing. So I think that's why everybody's out there looking for Redis clustering and how to do it the right way. And I'm sure that a lot of people have had conversations internally, should we use something like Thrift or like some kind of gossip protocol in between nodes? Should we have some sort of routing mechanism in front of it, like a proxy? Should we have some metadata store over here to map out which servers, which areas are holding which keys or something like that? I mean, there's tons of different ways that you can do it, but it just all depends on what your use case is, what your latency is going to look like, what your needs are. Obviously, we probably couldn't get the gritty details of how Redis Labs is doing clustering, but I mean, with a lot of the other open source clustering options out there, I'm pretty sure that we can guess as to decent ways to do this. It's just takes somebody to go out there and throw it out there.
And I think that's what's one of the other things I'd add to it is, again, in the process of talking to customers about clustering, when you start digging into the use case, there's some very valid reasons why you would want to. But a lot of times it's because it's new, it's because it's there, right? And when we talk through what the actual use case is, a lot of times we find it's not actually necessary for them to have a custom solution. There absolutely are use cases out there where they need it, and the size of their data set where they need it. But a lot of times we find that, when we engage with the customer and we start talking through it, and they say, well, I'm interested in a cluster solution. Why? What are the reasons why you're wanting to go that route? And by having that dialogue, what we find a lot of times is it may not be necessary.
Yeah, we've had the same conversations with customers about MongoDB, because we host MongoDB as well, and we have a lot of customers that want to use storage engines in the new Mongo 3.0. And everybody thinks that the storage engines are going to be just like MySQL, and it's going to be a pretty easy transition. It's still very new. They cut their teeth on a storage engine API just a couple of months ago. And they released it. It's not production ready. There are definitely bugs, and we've been working our way through them. And we have a lot of customers that are asking, hey, can we get some of the storage engines that are available? And I'm like, well, okay, what exactly are you looking for? Like, oh, no, I just want to run it because it's like the newest version. And, I don't know how many conversations that we've had to have. And just because it's the newest version doesn't mean you should have it. A lot of times, brand new versions you shouldn't be running in production anyway, at least not until you've done some sort of testing, smoke test, model test, integration test, everything.
By the way, what we see is a lot of cases where performance is important, not only the data set, and because Redis is a single threaded, there are many use cases where you actually have some capacity of single code.
Yeah.
Yeah, and that's where a lot of our conversations around splitting into multiple instances, that's where clustering, if we had a clustering solution for ours, that would be something where that would be the use case. A lot of times we see a lot of the people that we see with use cases, they can implement 2 instances. Magento is a good example. They can set a connect string in their sessions and a connect string in their full page cache. So it makes it really easy for you to cluster your usage of Redis with Magento because you can configure it in 2 places. It's not the most ideal. It'd be great to use one connect string and have that managed across multiple CPU processes and Redis running on multiple machines. But unfortunately, it's not everywhere all the time. So that's one of the challenges that we faced with being a service provider, is that we want to get something like that out to customers, but we have to kind of think outside the box when we don't have the option. So that's kind of where we landed. Yeah.
So being a hosted provider, you probably have better insights into what latencies look like in the real world as compared to like someone just doing a test bench, especially with that HA box in the middle. So I'm wondering if you have reports on what typical P50, P95, and P99 latency looks like, as well as access distribution over the keys, and what the working set typically looks like.
So we have a Redis engineer who's done a lot of this testing, and I think that he actually has a blog post about some of the testing that we've done. His name is Bill Anderson. I'd recommend taking a look at his blog. I think it's at therealbill.com. Yeah. So he has a lot of those metrics. He's done a lot of that testing for us. So I don't have those offhand.
What do people typically ask for?
What do you mean?
Like in terms of latency?
Sub-millisecond.
Yeah.
I mean, your customers do.
Yeah.
Sub-millisecond.
Yep.
Yep.
That's pretty consistent.
And that's,
Look, at the end of the day, they want something that, from a latency standpoint, is you're staying out of the way. You're not putting anything in place that's slowing Redis's capability down at all. And so the expectation, I think, is dead on. It's a millisecond. It's like if we run into an issue with a customer and they come talk to us about latency being an issue, it's because it's something that's over a millisecond or something that's closer to a second or 2. The expectation is it'd be dead on fast. It's Redis performance. And I think that's a really cool thing, that from a community standpoint, from a product standpoint, that expectation is there. We talk about it all the time. It's very, when a customer has a latency issue, it's very real, and there's a very real reason for it. And if we can't get it back down to exactly what you're talking about in terms of sub-millisecond, we're not making it.
And then you also have to think about, there's network latency, there's also command latency. So we see a lot of people now with large Magento data sets, and Magento loves to use sets, and we see a lot of times that they have S unions and S members being called that are taking, in the 50 and 80 millisecond range. So it's pretty interesting. I was trying to dig in and see if I could find some Magento source code before we came in here, and I found what I think is the source code, but I'm also thinking that Magento is not open source. But there was a comment in the code that says, we know that S-Union can have high latency in larger data sets, so it chunks it up. And it does like chunks of 50 at a time, or 500 at a time, something like that. So like, that's pretty interesting because I've seen that command latency, which we've got sub 1 millisecond network latency, that's fine. Except if you're going to overload the database with a bunch of information and then you're going to call a bunch of it at one time, then you're still going to see some of that. And that's what the slow log is super awesome for.
So Laura, how are we doing on time?
We have one super quick loading talk from Basho, so if he wants to pop up and...
Yep. Yeah, I wanted to make sure we were
He has a
respectful.
5-minute quick
You
one.
guys.
Let's give Andy
So with our data platform, we did some research and kind of looked into how people were using React in distributed systems in general. And one of the trends that we found was that a lot of people were using Redis as a front-end cache. So some people were using Redis as a cache in front of React, and really found that this gave a good synergy because React itself is a persistent data store. And we make some trades in performance for higher availability. And so Redis being as fast as it is, it makes a nice complement to Redis in a lot of solutions as caching. So here's a general overview of what our Basho data platform looks like with Redis. So there's a few pieces here. First of all, there's a service manager, and this is what's going to allow you to easily spin up Redis clusters. So we'll actually do the provisioning for you. You bring your own hardware, and it's pretty easy to actually set up a cluster of Redis using this. The other important piece here is the Basho Redis proxy. And this does a couple of things. First of all, it serves as a read-through cache, and that's part of V1 that's available today. And then we have write-through capabilities coming later this year, so that will be available soon. But the other important thing that this does is also provide sharding for your data. So with a Redis cluster, with that in mind, from your application's perspective, this is completely transparent. So you don't really need to understand how many nodes are behind that proxy, which really helps simplify your code and makes this really kind of easy to roll out. In fact, I've seen this been rolled out, so once they'll have the hardware in a matter of just seconds. So pretty cool stuff. And just so you know, the Basho Redis proxy was mentioned just a moment ago. This is actually Twin proxy. It is an opinionated version that we modified and provided as part of the platform. So I think that the real key takeaway here is that you can read it like Redis, but scale it like React. And this is something that is really kind of a strength for React as a persistent data store, being able to scale to whatever size you need and to do so easily and with operational simplicity. And then again, together with Redis, provides those sub-millisecond response times in addition to data durability. And we do offer a lot of conflict resolution options whenever you have network partitions or concurrent updates, for example, which is something that Redis doesn't do out of the box. So here is what a sample GET flow looks like with the data proxy. So essentially you issue a GET from your client to the proxy, and this will go to Redis. And if the object is in Redis, then we'll go ahead and return that back to the client. If you get a cache miss, what it'll do is actually go to React, grab the object from there and return it back to the client. And then also store it in Redis for the next GET. And so the next time you get that, it'll be cached automatically. Now, we do also have support for expiring via TTL. So if you have data that's not immutable, this is a good way to keep it fresh and completely configurable in terms of how often you're updating your data sets. So this is, again, just a very high-level overview. We have a lot more coming out with this. The data platform just dropped a couple months ago, so We're still on V1. Again, we're looking to have some future releases here pretty shortly. I didn't want to dive into a bunch of marketing slides because I know you guys probably want to get home to your kids or have another beer. So if you have any questions, feel free to hit me up. My email address is up on the monitor here. And happy to help you if you have any questions. So. Anybody have any questions right now? Yes?
Have you looked into extending this sort of proxy to sort of a publish-subscribe model where you have data that changes and you broadcast it out to everybody who's looking for it?
So right now, this is only going to be more of a caching solution.
Right.
I know that React and Redis serve a lot of different purposes, but for the purposes of the platform, it's purely in the cache in front of Redis. So I don't know if we've considered that for future iterations, but for right now, that's what it is.
So it's coming.
Cool.
That's all I can say.
All right. Neat.
That's the right question.
Yeah, if you want to talk some more, maybe we can set up that.
Any plans to implement
This
this?
is built in with Redis. What you ask is built in with Redis. The mechanisms that you can get notification for key changes. You're familiar with them?
Yeah.
So the key thing here is Redis would be a persistent backend.
Yeah.
React. Oh, sorry, yeah, React. Anything else?
Any plans to implement the cache proxy in native Redis Lua?
Sorry?
Yeah. So you talk to it in the native Redis protocol and the memcache protocol, and it will actually convert memcache and Redis commands to the respective origins of the data.
Very good. All right. Thanks, everybody.